Well, this is for my friend Mr. T. We're gonna, hopefully you guys can understand this. My friend Mr. T here is struggling with some health issues. Make sure I put this little ribbon back in my book here. He's struggling with some health issues, and I've been talking with him this last month and a half that I've been up in the hospital with my dad, and I told him as soon as I got a free minute, I was going to start on his box. So I got the two preceding builds that I have that are, if I was to do these in order, that come before this, I got to send the cabinets off to get them powder coated, and there's a lot of pre-labor that's got to go on with those other boxes, and I don't want him to have to wait, because I want him to actually be able to use this. This is a 24 pill enclosure, and we're going to build a 2x10 in it. The reason we're doing that is because I want the extra heat sink. I want him to be able to talk and talk and talk and talk his ass off. So we're going to build probably put 4 here, another 4 here, put the driver's section here, skip a couple, so we'll give it that much heat sink. And then in here someplace we'll put the other last 4 pills. So over here 8, over here another 4. Or no, he wants a 10, not a 12. What am I thinking? Shh. So put 8 over here, probably 2 here, or I'll do 4 and 4, and then 2 and 2. So I'll stagger it out. This is a lot bigger than what we need. We could probably fit this inside of a 16 pill enclosure. And I kept looking, I could have swore that's exactly what I bought for this particular build, but I can't. Oh, that's got stuff in it, that's got stuff in it, that's, nope, 24. This is where we're at. No problem. I'd rather give them more heat sink than not enough. So we'll build this out. We're gonna make this pretty. We're gonna put a big relay in it. We're gonna do our standard carousel splitter, combiner, that kind of thing. We'll bang the driver out over here. So we're gonna probably do 2 pills, skip a slot, 2 pills, skip a slot, 2 pills, skip a slot, that kind of a thing. So we're gonna utilize most of this heat sink, but we're gonna spread everything out. So on that note, let's make sure I got all the transistors, and which I'm positive I do. Let's start screwing them down. Moving right along here. So do I want to make this the driver section, or this the driver section, or this one, or this one, or this one, or this? I don't know. We've got all 10 transistors down, and we've got all of our 10 ohms down, our 120s down, we've got our metal clads on top of everything where it need to be. Yeah, I'm gonna go through and I put just a couple turns, 1 turn in each one of these, and I'm gonna go and I'm gonna put on input transformers. We're gonna start hustling right along now. It's gonna go pretty quick. Before I get much further, I think what I'm gonna do is I'm gonna drill the 4 power wires. One will go here, and one will go here, and one will go here, another one down here. I'll put the 4 power wires in this thing, drill the holes for them anyhow, and we'll put the power wires on last, because having all that wire hanging down is a pain in the ass. So moving right along, just thought I'd give you guys a little bit of an update. Next stop, input transformers, relay, output combiner, wagon wheel, carousel, however you want to put it. Input splitter, carousel, probably be somewhere in here. Drive section, blah 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 blah. Okay, so we're cruising right along. See, when we cut away, I think the input or output transformers are on. The input transformers are in. Everything's wired. The coax for the input sections is run. So how this works is the RF comes from the relay here, runs down, comes to the input of this 2-pill section here, comes out, comes out here, runs back on this piece of coax, goes over here, goes to our inductor with our capacitance tube, gets split 5 ways, and then it zips out, and it runs down, runs across, and all these coax links are the same. So it runs across through here, and it goes to these 3 input transformers. The output's now all wired in with these runs of coax that run over here to our output combiner. Got our little inductor and another capacitance to match up for the coax connector. So this will be a little bit fun to tune. I have not done the pass-through tune yet, and nor have I prepped up for the coax connectors, because I'm going to do all that once it's in the cabinet. We've got this relay over here, which is the key-in circuit. This white wire here is our sideband delay. This is our sideband delay circuit. The keying circuit activates this relay, which then in turn drops ground over here to this transistor, or to this relay. This is our bias output leads. If you guys noticed in the first portion of the segment, we have one wire that runs to this distribution pad, and then we have the 12 volt that splits off and goes to the load resistors. We have the exact same circuit built over here with the hot wire coming here, and then the 12 volt splits off to each one of the load resistors for the input circuit. Pretty clean build, if I don't say so myself. Looks pretty good. So we've got our red wire is hot, our black wires are return for our relay, and then the white wire is going to be the sideband delay. The only thing I have left to do now is to populate this with enough wire, put some type 43 on each one of these leads, have type 43 pop out over here with wire on it that are going to go to a Heiko strain relief and go out of the cabinet. So we've got, this is probably 89%, 90% done. The only thing left we got to do is, like I said, the 12 volt hot lead, and then wire all the switches, and then build the Sky remote. So on that note, we'll be back. I'm going to put some 12 volt wire in this thing, and we're going to call it a day. Gentlemen, I was starting to question if I could even get this far. We're done. I mean, we're done. Here is the lid. 2 high flow fans, BBI embossed Lexan. It's going to fit together something like this. I know that this is not conventional. Normally how I would do this is I'd have the 2 fans back here, but we have to keep in mind the quantity of the heat sink that we're working with here is vast. Way more cool scoochum than what we normally got for a simple 2x10. We normally would see this in a 16 pill cabinet, not a 24 pill cabinet, so therefore it is way overbuilt. I didn't want to put the fans right over the top of the input and output network. If possible, we want to move those away, so we're blowing down here on this dead space, air will curl back and blah blah blah. Shortens the distance to the end of the cabinet. More velocity, more air cool. Bam! Sorry, I'm excited because I'm really quite tickled with this box. It's working good. It's working really, really good. I did not have the simplest switch when I put this together over here for the sideband delay. It just needs a double pull, double throw, single throw switch. I didn't have one of them. I didn't. So I ended up having to use a relay. The $2, we'll say $1.50 switch got replaced with a $20 Omron. I went ahead and used an LED and a couple other things in here. I threw money away over here, and it's okay. I fully, totally embrace it. Let's go in here and take a look at how this is wired. Our RF comes in from here, runs down, shows up over here. It comes here, goes in, amplifying things happen. We do an impedance and matching with some capacitance. The RF comes out, runs over here to this input board. We use this tuning tube, once again, to drive and change the inductor with an inductor, blah, 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 turn it back into 100 ohms, da-da-da, match the ports. We got a 5-port split with 3 wraps. And then all the signal comes out, runs down this racetrack. Na 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 Batman. So then it hits this stage and this stage, this stage, this stage, and this stage, all at the exact same time. How does that happen? Through magic and pixies and baby's tears. No. We just make the coax links all exactly the same. That way we're dealing with the same amount of coupled resistance through the form of coax. I watched a whole video about coax last night. He used big words. I was really proud of him about coupled, inductive, paralleled circuits and how they have a proximal capacitance coupling that takes place and how we derive at our 50 ohm measurement. It's really neat. It's a theoretical resistance number. We're not going to get into that. That's not what this is about. Not that I didn't know how coax worked. It was neat to learn all the new terms and to think about it like that. We apply the same principle on the output side of the network. Okay. There are people that will tell you that these coax lengths don't matter. We just want to make them as short as possible. I argue to the other end of the spectrum. I feel that all the coax lengths should be the same, all the components should be measured the same, and all the parts need to be equally blah, 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 blah. We've all heard me say these things many, many, many times. So once again, then all of our RF shows up back over here through magic and baby angels' tears, the pixie dust of fine women in the Arab countries, and bam. Once again, to return, we utilize an inductor with capacitance to drive us back over to 50 ohms. We have a way super oversized relay. This is like almost an excess at this point. And it goes out through our Teflon. Legit, bought from Max Gain Systems, by the way. PL250 or SO239 panel mount, coax connectors, and then we're going to run that out through our RG400, through our 5-watt slug in reverse back from the Bird 10,000 watt dummy load, our 1,000 watt slug going forward in average, and a 1,000 watt slug going forward in peak. This average number is bullshitium. I don't believe in it, but it's how most of my guys speak, so therefore I have to go and use that term. Hence the reason why I say whatever you want to call it. It's the Bird 43, which was never designed to read anything on AM with the element in it with no peak kit involved. Okay. Sorry, I'm being a little sarcastic. It's way, way early in the morning, and I'm just totally grateful that this box is running as well as it did, or does. The problem that I ran into is I started talking with some of my fellow peers in the amplifier field, and I listened to how they say they set up their 2x10s and their results they're getting, and I have to remind myself constantly, but I forgot it for literally like 6 hours, 8 hours. My output transformers are different. My input transformers are different than what are commercially bought. These are custom made for me, at least they were. Now they're going to be done in-house as soon as I can get a company that will print these for me, which is a big pipeline issue for production for me, by the way. So I need to get on that this week. My input transformers are 100% done in-house as well, because dimensionally there's more surface area. I have to use a different amount of capacitance. So it has been a long time since I built a 2x10. I don't even know when the last one was I built, but I had to go get back into my books and look at what I had for capacitance. It was a Toshiba base box, so I had to go hunting for my input capacitance, output capacitance, and input transformer capacitance. Where I ended up was on my notes for a 2-pill section, because if we really think about this, we have a 2-pill section driving a 2-pill section, 2-pill section, 2-pill section, 2-pill section, 2-pill section with a splitter, and then the output of each 2-pill section comes together in the combiner network. For a hot minute, my brain went whoop, and I forgot that I have different capacitors here that I have to use. And I went back and I looked at my 2-pill nodes for HG and went, oh yeah, it cost me half a day. 7 hours worth of time totally farting around. So to double check my capacitance values, because the parts from China constantly change a little bit up and down in the quality, I went in and I busted out this 2-pill section, ran it by itself, bypassed all of this mess here, removed this mess from the circuit, basically unsoldered it from here, took another piece of coax, went from here to here, and ran it. And it all came up. Now, this is the sticky bit. We all know that each 2-pill section will make roughly 500 to 600 watts peak envelope power, mono-banded and a little bit saturated and maybe a little bit on voltage. So like at 15.7 volts, 15.5 volts, we'll see about 600 watts per 2-pill section. So how that translates to you guys is that normally when you look at an amplifier that is built somewhat in this style, I'm talking the X-Force, Dave made, fat boy-ish kind of thing, with the 16 D08s, we need to think 500, 500, 500, 500, 500, 500. That's the amount of total watts. So 500 here, 500 here is 1,000. 500 here, 500 here is another 1,000. There's 2,000 watts worth of amp. Here is another 500 watt amplifier. So if we see 1 watt over 2,500 watts, we're doing good. The new 2879Cs. Just got done working through that problem as well here just a few weeks ago, something we were doing on the side. We figured out that, well, they've changed. And the other thing that we figured out is that a lot of guys want to drive the holy bejesus out of them, and really you can get even better performance if we change our number of turns here, our capacitance here, and capacitance here and here. We'll show you. You'll see. Yeah, if I could ever get time for it, there's also yet another transistor that's out there in development that will surpass the C's by a country mile. But it's okay. We'll come back to that on another day. For today, what we're dealing with today is that we need to have this 10-pill section of the amplifier run smoothly for sideband for my customer where it's going. So first off, with the amplifier off, the other thing I want to point out on a fun side note is that the LED on the front does not come on until we turn the sideband delay on. This guy works a lot of sideband. He's going to be hitting it with, I think, an ICOM or something like that, I do believe. So better make sure my tune is spot on. I want to point out that the jumper between the radio and the amplifier is 18.5 feet, because that's the null electrical length for RG316. Please don't make me do a video on nulling out coax again and talking about resonant wavelength for frequency and capacitance and velocity, please. Customer needs to know this. That's the reason I'm pointing that out. Okay, so we're going to start out with low drive. We're going to start out with our bench over here. Bench 2950, which we have turned way down so I can beat the holy shit out of it. Ready? I think I've covered all the steps that we need to cover. Oh, almost gave away the cookies before the milk. Hello, 1, 2. We are on right now about 11.5, 12 volts. So we're going to operate this like the normal person would see it if they're running this on a 12 volt power supply. Then we're going to turn on the bench power supply, which is, by the way, getting ready to change here this month. You guys better hold on to your underwear because you're not going to believe what I'm going to build myself for here. No, this power supply I'm building in the future is not for sale, by the way. Hello, 1, 2. Hello, 1, 2. So we're putting about 20 watts into this amplifier. Let's take our 5 watt slug and make it read forward for a minute. Our base dead key is 1/2 of 1 watt. 1/2 of 1 watt. Which is not even enough to really get the transistors to turn on, but 1/2 of 1 watt gets us a 200 watt carrier. Hello. Hello. 1/4. Okay. So we're going to go up to 2x. Let me get myself a pointy tool. Let me switch sides of the camera. So, when we turn on the peak kit in 2x, when the needle goes from here to here, otherwise known as full deflection, when the needle reaches the end of its meter movement, that is 100%. So we're now reading in a 2000 watt scale. Directly here in the middle between 40 and 60 is 1000 watts. 60 is now 12. The next big hash mark is 14. 16, 18, 2000 at the end. Remember, we are driving this low. We are not going to see max performance watts yet. We will here in a minute. Hello, audio. Hello, audio. So we're seeing about 14 to 1600 watts peak and about, hello, what, 380-ish bird. I know. The numbers are low. Let's go up here and let's look at our input tune. This is a 5 watt coaxial dynamics element that sits 1 foot. There's, pardon me, you got 1 foot worth of coax, and it's on a shoestring that goes from the 2950 over to this bird meter. Off that other elbow on the right hand side, this one here, is where the 18 foot of coax starts. So this would represent what your radio is going to see. The meter is in reverse. So I'm reading the power coming back from the amplifier. 1, 1, 1, 1, 1, 1, 1, 1, 1. So less than, oh, let's see, that's in tenths. Let's see, 1, 2, 3, 4, 5, yeah, tenths. It's less than 200 mils worth of reflect with 20 going in. That's really, 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 really good. Okay. We're going to repeat this whole process in just a second. Sorry, I'm just in a very weird place in my head tonight, so my attitude being a little off, please don't give me a hard time here. I'm trying to stay motivated and have fun and be energetic. I feel like I'm on a treadmill now. Or an organ grinder. One of the two. Okay. All we've done now is we have turned on a power supply and we're going to go to 15.5. So we're going to run it up a little bit. Nothing else in this entire equation has changed. Nothing. Not the radio, not our coax, our hands haven't been inside the amplifier. None of that. None of that has changed. So let's zip in here. Hello. We hit the stop peg, folks. The stop peg is about 200 watts over. So if it's on a 1000 watt scale, we're going to see about 1200 watts if we're hitting the stop peg. A 2000 watt scale, we're going to see about 22-ish, something like that, I bet. So now we're going to jump down to the 5x scale. The 5x scale is really fun for me because now we have to use our big brain and think just a little hot minute, which I think after over 1,000 plus of these videos of me explaining this, there would not be a single living creature on the face of the earth that had not seen what I'm talking about. When I hit the multiplier here, we're now reading that bottom, or pardon me, that middle scale. 10 is 1,000, 20 is 2, 3 is 3,000, and so on all the way out to 5,000 watts. We're going to be somewhere around in this department, 2,400 watts. Okay. Okay. Oh, audio. We're not doing half T-bag. We're not. But BBI, you didn't show us drive from the radio when you increased the voltage. You, Bleacher Creature, are correct. Make sure to leave me a comment down in the doobly-doo how you telepathically told me that. So, we're back down on 1,000 watt scale. Hello, 1, 2. The voltage caused the drive to go up by 8 whole watts. So we went from 1700 to 2600 by feeding the right voltage to the components. Just saying. Now I want to show you guys something. We're going to change radios because this thing can be driven more. Now, according to what I just laid out to you, the rule, the 500 watt rule, we're seeing 500 watts peak. Okay, we're done. We hit our 2500 watt mark with 28, well, about 30 watts of drive. We'll say 30 watts. We'll be generous and say 30 watts. 30 watts of drive. If you want this amplifier to last forever, when Jesus comes back and is playing a flute through his wrist, you'll hit this with 35 watts, 30 to 35 watts, and it'll last you forever. Now, there are people out there that go, but BBI, it's got two 2879s driving 10 2879s. I've got a friend that was swaddled as a child and boarded and dropped several times on his head, and he tells me out the side of his neck that I should risk all of my components, my amplifier, and the chance of blowing it up by driving it with a 100 watt radio because it can take it all day long. It can take it, but for a very short time, and I strongly suggest that we don't do this, especially on sideband. On sideband, I would say to your sloped-headed friend, where his eyebrow is one continuous growth form that comes out of his forehead, stop it. Stop talking like that. Stop thinking like that. It is possible to drive this with 100 watts. It is not recommended, not by the builder and not by anybody involved. I would say the max I would ever want to put in this on a continuous basis or on a daily would be about 40. Okay. We're going to run this up to its max, and we're going to see the difference between 30 watts worth of drive and 120, 130 watts of drive. That is the theoretical max input for this 2-pill driver section. That does not mean that the theoretical max input of the 10-pill section is 600 watts. Hello, 1, 2. Doing about 120, 125 bird, or 120, 25 peak. Listen, if we break it down by the math, when I drive this 2-pill section here, right here, with the 100 watt radio, 120 watt radio, we are causing the transistors to be oversaturated and possibly distorted a little bit. It works great on AM, not so hot on sideband. This 2-pill section max does about 600 watts. Okay? Okay. So 6 times, or pardon me, 5, so that's 1, 2, 3, 4, 5. 5 sections times 600 watts apiece. Okay, so 600 times 5. In theory, this thing should do somewhere around 3,000 watts. I bet you that we get around 28. What do you want to bet? So, here's the next thing. Is we know, for effectonio, that each transistor takes roughly about 25 watts worth of peak power apiece. Max drive. On the data sheet, it says 12. Of course, on the data sheet, according to their RMS, whatever they were using when they drove the transistor, that it only does 125 watts apiece. That is in a flat, non-responsive palette that is designed to operate on a large spectrum of frequency. We have hyper-tuned this palette to work on narrow frequency only, hence the reason why we don't need any filtering circuits on it, but then we're able to supersaturate the component and get more out of it. I digress. I didn't write the data sheets. I wasn't even born. Okay, so 25 watts worth of peak power drive times 10 is real simple math. It's 250 watts. Once again, with a 100-watt radio driving into this. By the way, you put 30 watts worth of drive into this little 2-pill section. It puts out about 230 to about 280 watts of drive. So we're right within the drive window for the rest of this amplifier. Okay. Not the full chooch 600 that we're going to vary for a short minute slam into all 10 of these transistors. I only do this a couple times. If the owner of the amplifier decides that he's going to operate it like this, that's on him. The last time I checked, ICOM radios like this have a knob that you can turn the power down. And we're going to want to utilize that, because then that means the ICOM stays cooler, everything stays cooler, everything lasts longer, we're happier. And we're not fully saturating the drive section of the amplifier to oversaturate the final section. So we're trying to establish kind of like, hey, I don't know if you guys caught this when I did the interview with Tony from Fat Boy. Some of the things that we used to be able to take for granted with the Toshibas, because by the way, the Toshiba is a superior component in all shapes, forms, fashions, and operation. We need to start taking it easy, yo. We need to start thinking about this like responsible adults. We're not all in the shootout truck doing 21 volts trying to get, 2,500 bird out of our stuff. We need to think about it on the daily operation for safe and not having anything fail. So, just saying. I'm going to demonstrate this and then we're going to move on. I bet you we get around 2,800 watts. What do you guys think? Let's make sure that I got my peak kit down in 5X, which I do. Here, let me show you the difference. Amp is off. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So what 120 watts looks like on a 5,000 watt peak scale. Oh, sorry. Hello, audio. 2,900 watts. Mic, drop. Okay. So now that we've got all of that information loaded up into your brains, let's look at our input, even though we're super saturating the component. Let's look at the scale here. This is really important. Hello, audio. 2 bars, which translates to, we'll look up here. It's the same situational setup. We have a 1-foot jumper that goes from here to here. Why do we use 1 foot? Because it's mostly non-resonant. There's not enough time at this frequency for the coax to have a coupling effect on the tune. So therefore we can get ourselves away and say, okay, we're close enough. Once again, coaxial dynamics, brand new slug in reverse on a Bird 43 watt meter. It's a $600 setup there. No, let's see. $300 for the meter and $100 and some for the element. So $400 and some meter just to show you the input reflect on this amplifier, not counting the cost of the coax, right? Fun stuff. Hello, 1, 2, 1, 2. We're seeing 500 mils or less than 1 watt or less than a half a watt worth of reflect coming back from the amplifier. That's really good. That's how that translates. Now, the reason we're squealing, because I have the cabinet open, number 1. And number 2, I got a computer speaker sitting right over here out of frame that the RF is, because of proximity, getting into it. This thing is perfect. I am beyond tickled with how well this turned out. I cannot work on this anymore because there's nothing left for me to do. Hello, 1, 2, 1, 2, 1, 2. About 800 bird with my derail bench radio driving it. I could get it to do a whole lot more bird if I'd use like a Cobra 29 that has been race car modded like some of the other builders do. I've never understood that. See, the way I look at this here is that this radio right here, the average everyday radio operator is going to be able to afford it. This radio right here, you know, the striker itself out of the box is one thing. That has been across D-Rail's workbench. I had to put a variable peak and variable bird on the side of the radio, and I can make it do anything I want it to do. I can make it operate just like this, or I can make it operate like a hot rod. This radio here, on the other hand, which you guys hardly ever see me use, is a D-Rail shootout comp radio. This is the 4th or the 5th one in the country at the time. That radio, that Cobra 29 weighs about 9 pounds, and it's because of the giant ass heatsink that's on the inside of it, solid copper. This radio here produces an absurd amount of bird watts. And what I mean by bird is we can make this meter. The reason that none of us are really paying attention to the bird meter anymore is because that is a variable. What do you mean by it's a variable? Well, I now have a knob on the side of this radio that allows me to make this meter right here read whatever I want it to read. Okay. This radio here injects more modulation in the AM side of things, which makes this meter read even more generous. The problem is the peak meter never changes. I can hook up this radio here, which has none of that fancy shit in it. This is literally a straight out of the production, off the production line. The only thing I did is I went in and I turned the drive section, the pre-drive section way down, so the finals wouldn't get super saturated. So I could literally key it without a coax connector attached to it. I don't have to worry about blowing it up. I can use this radio here and this radio here. Okay, the $700 Super Comp Shootout Special Slam Jam D-Rail Land radio. These two radios produce the same peak numbers. This one has low average because the modulation limiters and all that stuff is still in it. This one, all the modulator limiters and all that other crap's all been pulled out of it, and it produces huge bird numbers. Like huge. I can build a 16 pill with that D-Rail radio hitting it that does like 3,800 bird, but it still only makes 4,000 watts peak. So, needless to say, we're done here. There's nothing left to do. The only thing I got left to do now is to spray this whole thing down with clear so this beautiful craftsmanship of the board and all the components and all that stuff have a little bit of a moisture barrier on them. I know where this amplifier is going. It is cold. And it is moist. Even more moist than a moist towelette is where this thing is going. I did an amp about 4 days ago. You guys haven't seen the YouTube video on it yet. And I picked up what I thought was a can of clear, and it ended up being a can of CLP. So I almost sprayed the inside seal like here. Almost sprayed the inside of one of the amps with gun oil. I was like, oh shit, oh shit. That would have been bad. Bad Jackie Chan. Okay. Now all I gotta do is let this vape off, cook off, gas off, however you want to put it, and it becomes paint. That does nothing for anything on the inside of the box. That level amount of paint does not change the conductors on anything, does not change anything, does not add any insulation value. Like if I was to take a wire and drop it from here to here, we are gonna have a spark. All we're doing is sealing the pores of the metal so that when I come back in here in 10 or 15 years, all I got to do is take an air hose, blow all the dust out of the inside, and it won't be all gajizzled, crusticled up on the inside, and the board won't be corroded. For a lot of years, guys didn't do that. They didn't do this one simple step. They didn't seal the copper. So we get the amplifiers back and the boards are green, and there's little fine hairs of mold growing up all around all the component legs and stuff. I'm going to put some labels on this, and I am going to put the logo on the front. We're going to put the lid on this amplifier, and we will be back. So it dawned on me as I was ending that last segment, Luke, you never ever showed this thing operating on sideband. And I'm like, oh yeah, totally forgot. So we got our bench 2950 hooked up. We're in lower sideband. Our sideband delay button is flipped. I remember somebody saying to me, I do believe it was the customer, that he doesn't like the multicolor LEDs. You want to just blue. I was like, okay, you got it, bro. So sideband switches up. I said, under that old Model T was the place she first showed it to me. It was big and black and she called it her crack, but it looked like a manhole to me. Hello. 261 amps worth of pullable shmew. Look, the guy initially came to me and he said he wanted to be able to do 2,000 watts on sideband, 2,500 max. That's what he was looking for. I said, then you want a 2x10. This is what I built him. That's 1,000 watt slug in average. It's an unaltered element. This is a 1,000 watt slug with the 2x multiplier implied. Hello. We're laying both elements hard into the corner. And this is with 30 watts of drive. Hello. This thing with 30 watts of drive will make easily on sideband like 22, 23, 2400 watts worth of power, and it'll live like this till the cows come home. Okay, just is what it is. Gentlemen, I want to say thank you. So down here in the bottom, you're going to see right about in here somewhere there, these guys. They're the Patreon supporters. They're the ones that actually make all of this go down. They are the bread, the butter, and everything that goes on with this situation. They have access to a whole lot of content behind the scenes that most people don't get to see. If you have an opportunity, come create a Patreon account and come join us. I'd like to put a shout out to Penna Labs, Excess Power, Siglent, Bird, MechMan, Coaxial Dynamics, all proud sponsors of this channel. Gentlemen, I say thanks to every single one of you that support me, that follow along, give me a thumbs up, and you've clicked subscribe and made sure to hit the bell so you get notified every single time a YouTube video comes out. And on that note, gentlemen, I said I'll see you. Click, click, click.